Next up is substitution and elimination. Now, one of the ways that we can solve a system of equations is by graphing. But we don't really want to use this method because if we have any answers that are fractions, it's going to be near next to impossible to figure out exactly what the fractions are on a coordinate plane. So rather than graph, you're better off doing substitution or elimination. So we're going to look at the system 3x plus 4y equals 12 and 2x plus y equals 10, and we're going to use substitution to solve this. Now the first thing that we've got to do is we've got to choose one of those four variables to isolate. So it's either going to be the 3x, the 4y, the 2x, or the y. Since the y in the second equation has a coefficient of 1, that's the one we want to choose to isolate because it's going to cause us to use the least amount of steps to get to the isolation. So we start by going 2x plus y equals 10, move the 2x over to the other side. So now you're left with y equals negative 2x plus 10. We know what y is equal to. So we can now take the equivalent of y and plug that in for y in the other equation. So that's going to be 3x plus 4 times negative 2x plus 10 equals 12. Now we're left with just one variable to solve for, and we can do that easily. Distribute your 4, then you're going to take your like terms, combine those together, and you're left with negative 5x plus 40 equals 12. Move your 40 over, and you're left with negative 5x equals negative 28. Divide out the negative 5, and your solution for x is 28 over 5. Now that you know what the value of x is, you're going to put that into the first equation that you chose, the 2x plus y equals 10. One of the things that you have to remember with substitution is you have to change back and forth between the equations. You can't use the same equation twice in a row. So what we're going to do now is go 2 times 28 over 5 plus y equals 10. Again, we're at a point where all we have to do is solve for one variable. 2 times 28 over 5 is 56 over 5, and we're going to have to subtract that over to the other side. So let's go ahead and take that 10 and make it into a fraction with a denominator of 5, which is going to be 50 over 5. Subtract the 56 over 5, you're left with y equals negative 6 over 5. So your solution as an ordered pair is going to be 28 over 5, negative 6 over 5. Now, as with all equations, you want to go ahead and you want to substitute the solutions back into the original equations to make sure that you've got the correct answers. Now, since we just used 2x plus y equals 10 on our last step, we now need to use 3x plus 4y equals 12. So you substitute your two solutions into that equation. You've now got 3 times 28 over 5 plus 4 times negative 6 over 5 equals 12. 3 times 28 is going to give you 84, so 84 over 5. 4 times negative 6 is negative 24 over 5. 84 minus 24 gives you 60 over 5, and that is going to reduce down to 12, and 12 does in fact equal 12, so you know you've got the correct solution with 28 over 5, negative 6 over 5. In this second problem, we're going to use substitution to solve a word problem. So a music store offers piano lessons at a discount for customers buying new pianos. The cost for 6 lessons plus the fee is $300. And the cost for 12 lessons plus the fee is $480. What is the cost of a single lesson and the fee? So in this one, we know the total cost for 6 lessons plus the standard fee is going to be $300. We know the total cost for 12 lessons plus the standard fee is going to be $480. So we can go ahead and set up two equations. 6L plus F equals 300, 12L plus F equals 480. So same thing that we're going to do as on this one as we did with the last one. we're going to look to isolate one of those variables, one of the four variables, either the 6L, the F, the 12L, or the F. What you want to do with this one, go ahead and isolate one of the F's. And I'm just going to go ahead and choose to do the first equation. So we're going to isolate F by moving the 6L to the right side. So now we've got F equals negative 6L plus 300. We again know what F is equivalent to. F is equivalent to negative 6L plus 300. So we can take that quantity and we can plug it into the second equation for F. So when we do that, we have 12L plus the quantity negative 6L plus 300 equals 480. Combine your like terms. You're going to be left with 6L plus 300 equals 480. Subtract 300 from both sides, so 6L equals 180. Divide out the 6, and you get L equals 30. So we know that a lesson costs $30. We're now going to take that $30 and we're going to plug it back into the first equation, because remember again, you've got to go back and forth between them. So we're going to go 6 times 30 plus F equals 300. 180 plus F equals 300, subtract your 180, F equals 120. So now we know that the standard fee is $120. So we've got an ordered pair of 30, 120. Now again, what we've got to do is we've got to check our work. Plug it back into the second equation, 12 times 30, plus the fee of 120 equals 480. 12 times 30 is 360, plus 120 is 480, so 480 equals 480. We've got the correct ordered pair of 30 and 120. In problem number 3, we're going to solve by using elimination. So in this system, we're given 4x plus 2y equals 9 and negative 4x plus 3y equals 16. Now what you want to do with this, with elimination, is to go ahead and stack your two equations so that you have your x's vertically aligned, you have your y's vertically aligned, and then you have what they're equivalent to vertically aligned as well. Now, in substitution, we had 4 variables and we decided which one of those 4 variables did we want to isolate. In elimination, what we're going to do is we're going to look at the 2 variables, the x's and the y's, and we're going to decide which one do we want to get rid of, which one's going to be easiest to get rid of. So when we stack these, we see that we have a 4x and a negative 4x. Well, what is 4x minus 4x? It's 0. So with this problem, it's basically chosen for us. We just go ahead and eliminate the x's. So we are left with 2y plus 3y is 5y, and 9 plus 16 is 25. So you get the equation 5y equals 25. Divide out the 5, and you're left with y equals 5. Now that you've got one of the variables and you know what it's equivalent to, then we take that value and plug it back into either one of the equations. So on this one, I'm going to go ahead and plug it into the first equation. We're going to have 4x plus 2 times 5 equals 9. Go ahead and work out your math, and you've got 2 times 5 is 10, so 4x plus 10 equals 9. Subtract the 10 over, you're left with 4x equals negative 1, and then you've got x equals negative 1/4 once you divide out the 4. So now that we've got x equals negative 1/4, we've got both our x and our y values. We set them up as an ordered pair, negative 1/4 and 5. Again, go back and check. Since we used the first equation to find the x, now we're going to use the second equation to check our work. So we're going to go negative 4x plus 3y equals 16. We're going to plug in negative 1/4 for the x. So negative 4 times negative 1/4 plus 3 times 5 equals 16. Well, a negative times a negative is a positive. 4 times 1/4, or 1/4 of 4, is 1. Plus 3 times 5 is 15, so 1 plus 15 equals 16, and 16 equals 16. So again, we know that our ordered pair of negative 1/4, 5 is the correct solution. In our fourth problem, we're going to go ahead and learn how to solve an equivalent system. So we're being asked not what the solution to the system is, but how many solutions does each system have? So we're given 2x plus 7y equals 4 and 3x plus 5y equals negative 5. I'm going to use elimination. So I'm going to stack these two equations so that I have 2x over 3x, 7y over 5y, and 4 over negative 5. So I've got to choose which one of these variables do I want to eliminate. The x's have the smaller coefficients, so those are probably going to be the easier ones to work with. So what I need to do is I need to make sure that I'm finding out what is the least common multiple of 2 and 3. And the least common multiple of 2 and 3 is 6. So I'm going to multiply the top equation by 3 and the bottom equation by negative 2. Because remember, I want to be able to subtract these two values in order to eliminate them. So when I multiply those through, I'm going to be left with 6x plus 21y equals 12, and negative 6x minus 10y equals 10. The 6x's are going to eliminate. 21y minus 10y is 11y, and 12 plus 10 is 22. So now I've got 11y equals 22, divide out the 11, and you're left with y equals 2. I now want to take that 2, and I want to plug it into one of the original equations. So I'm going to again choose 2x plus 7y equals 4, and I'm going to plug the 2 in for y. So that's going to leave me with 2x plus 7 times 2 equals 4. Go ahead and work out your math. 2x plus 14 equals 4. Subtract the 14 from both sides. 2x equals negative 10. And then divide by 2, x equals negative 5. So now I know that y is equal to 2 and x is equal to negative 5. And now I've got a solution of negative 5, 2. And that tells me that I've got one solution. I'm going to go ahead and check my work and make sure that I've done this correctly. And I've got 3 times negative 5 plus 5 times 2 equals negative 5. So negative 15 plus 10 equals negative 5. And then negative 5 equals negative 5. So I know that that solution is correct. And I know that I've got one solution to this system. Again, on this next problem, I want to figure out how many solutions does this system have. So I'm going to line up my two equations, negative 3x plus y equals negative 5, and 3x minus y equals 5. And I'm going to stack them vertically again. Now I've got negative 3x plus 3x, so I'm left with 0. Y minus y, so I'm left with 0. Again, the entire left side is now 0. Go over to the right side. Negative 5 plus 5 is 0. So now I'm left with the statement 0 equals 0. That is a true statement. So what this means, because I've got a true statement and no variables left, this means that any and every single number in the real number system is a solution to this problem. I could plug in negative 1, 5, 10 million, and every single thing that I put into this is going to give me a true solution. In this last problem, we're going to see what happens when the opposite happens. So again, I'm looking for how many solutions does the system have. So we've got 4x minus 6y equals 6, and negative 4x plus 6y equals 10. Stack them vertically. 4x minus 4x is 0x. Negative 6y plus 6y is 0y, so I'm just left with 0 on that side. Over on the right side, I've got 6 plus 10, so I get 16. So I'm left with the statement 0 equals 16. 0 does not equal 16, so the statement is false. What this means is that there are no solutions whatsoever to this system of equations. So there is nothing that I could put into either x or y to make those two equations equivalent to each other. So what you should take away from this section is that there are 3 possible numbers of solutions for a system of equations. You can either have one solution, which is going to be an ordered pair. You can have infinite solutions, which actually means that the two lines are the exact same line, or you can have no solutions, which means that the two lines are parallel.